Greetings friends, in this video I'll try to bridge some gaps, some potential gaps in your understanding in this beautiful subject that is engineering graphics in AutoCAD, and I really hope that the title of this guide, that is Intuition Maxing, actualizes in your life as you watch this video. I'll start with how our practical went. We got 1 hour for the practical in the Viva in the lab, and we had 1 hour to write the theory questions and the procedure. The two theory questions that we got were 5 commands we got, and we had to explain them. So I highly recommend learning these. You should learn all 3 of these. By the way, a quick piece of info: when you're using Notion, you can click on this button to toggle it. Don't just feel me? Yeah. These were also asked in the Viva. He randomly asked list 5 commands, and he made a face when someone said line and circle. So please use these. Applications of projections. These are very common Viva questions, although I haven't seen them in theory. And shapes as well. Very basic, you should know this. And the full form of CAD, computer aided design, and why we use it, you should know this. And YouTube tutorials, please watch. They're incredible and they will definitely help you understand. Everything's been explained step by step. The 4, I would say, important drawings are 3D to 2D and section of solids and perspective projection. Please practice these 4, and 3 of them have videos, and the 4th one, the perspective projection one, has I skipped one, which is isometric. That's also important, the magnet that we made. IT got this today. This is isometric projection. Please practice this. This guide took me hours to make, and it's got these annotated screenshots. And if you try to make it, if you use this guide as a follow along, you will 100% understand it. But I will explain it a bit more in just a second. So I'll start with explaining first angle versus third angle. So it's I think you should just learn a little bit. Observer, object, and the projection plane. If the object is between the observer and the projection plane, then it's the first angle projection, and this is what we use. And if the projection plane is between the object and the observer, it's a third angle projection. So the main difference is that in here we draw the top view is the top view is drawn below and the front view is drawn above, and the right side view, instead of being on the right side, it's on the left side. So this is what we have to keep in mind. In questions, you will be, for example, the question that we got, this is what we got: using first angle projection method, draw this. So this image that we have, let's say you get this in the question paper, then what do you think? This is the isometric view. It's the isometric view, and you have to convert it into orthographic projections, 3 of them, which have been listed here: front view, top view, and right hand side view. So this arrow indicates where the front view of this thing is. So what I want you to do is, what I did was, I had a rough page with me, and I briefly, very quickly sketched a rough diagram of what the final drawing should look like. So first of all, this front view, we will be drawing this. Let me show you. This is the front view, and this needs to be drawn above this plane. And the top view would be something that we see from here, and this is what this would look like. You feel me? If we're looking at it from the top, this is what we would see. So quickly sketch something out, and you'll be way quicker. And after this, the main 45, and extend these, project these, and wherever these meet, you have to trace it. This 45-degree line is super important. So the right hand side view we got on the left side. This is the front view and this is the top view. So what is isometric projection? The different types of projection are, did you understand this? First versus third angle. In third angle we do this, but in first angle the front view is drawn above, the top view below, and right hand on the left side. Projections hierarchy. First is the perspective projection. It's like the most basic, where the observer can be anywhere. The observer, by the way, is the station point. So look at this. Let's say you're in isometric view. Let's say you're in perspective view. This is what you would be seeing. But if you zoom out really far in this perspective view, and at a very particular angle, you would be, what it would become is isometric view. Do you feel me? Do you see this difference? Isometric is not a type of perspective projection. I'm only saying this to explain it. When, like, this photo has been taken from 20 centimeters, and this is what it looks like. So this feels like perspective, doesn't it? This feels like perspective, while this feels more like isometric. And see, this is isometric, and this is what we got in, this is what you see in the question paper. Now what they want you to draw is the orthographic views. So the front view like this, okay, like, you know, it glitches a bit, but you get the point. And the right view, this is what it wants from us. Let's take this house for an example. In perspective, you can see, like, what's closer to us moves faster than what is farther away, and you can feel the difference of how, if we zoom out till infinity, we will reach isometric view. See how everything just feels at perfect angles. There's no distortion happening. There's no that fisheye effect that we get during selfies. This, if you're really close, this is what you feel. And you see, the further away you are, the more details you see. And I think this is as much intuition as you can get how perspective becomes isometric. And in isometric, when you're viewing it at a 90-degree angle, that's orthographic. An oblique one, the oblique projection, is the weird one out. You see how the top is perfectly visible, but these sides that are supposed to be at 90 degrees are at 45 degrees. So oblique projection does not exist in real life, but all of these three do. I'll move on to perspective now. What do you do when you get, first of all, learn these. These are asked many times, so please learn these terms. Let's say you get perspective projection. The question that we got, this one, this is of a 2-point projection system, and this is of a 2-point projection, perspective projection. And like, if you get that, I would say, just, if you have a choice, please go for the second one. First one, if you can, watch a tutorial. Otherwise, I mean, it will take some time to learn. And let's say you get a normal one. This is the picture plane, which is PP. So let's read the question, because in the exam you will only get a question. A rectangular pyramid of sides of base 30 millimeters and 20 millimeters. So this is the rectangular pyramid that we have drawn here. It's 30 by 20 in height 40 millimeters. Rests with its base on the ground such that one of the longer base edges is parallel to the picture plane. So longer base edges is parallel to the picture plane. So we start by drawing the picture plane, and you see the first step is draw a reference line PP, and after that we draw the rectangle. So start with drawing the reference line, which is the picture plane, and then draw the rectangle. Edges, one of these longer edges is parallel to the picture plane and 15 mm behind it. So 15 mm behind the picture plane. So how do I know that behind is this? See, in the lab manual, this picture really helps you understand. This is where you are, and this is the picture plane, this vertical, and this is where the object is. So if you're looking at it from the top, which we are doing right now, the object is behind the picture plane. So that's all it really means. We're looking at it from the top. We're looking at it from here. So the picture plane, which is a plane, appears like a line. This appears like a line when it's actually a plane, because we are viewing it from the top. And a pyramid only looks like a rectangle from the top. So 15 mm behind it. The observer is 15 mm in front of the picture plane. So this observer is standing 50 mm in front of the picture plane. 25 mm left to the side, left to the axis of the pyramid. So this is the axis of the pyramid, and it's 25 mm to the left and 50 mm above, in front of the picture plane, and 50 mm above the ground. So 50 mm, this is the ground, and this is where the station point is, where the eyes are, where the observer is, like where the rays are converging, and it's 15 mm above the ground. This is the 50, the last 50 that we see, the 50 mm above the ground. This is that. And from here, like this above part, this much, this is the top view. But when we transition to this HL and GL, this is HL and GL. So this is the actual, I guess it's the front view, which we are seeing here. Not the front view, but like this is what the observer is actually seeing. The guide goes, like, explains really well why, like how to draw these lines. You can use color coding, but I mean, it depends. So we start by drawing the reference line, then we draw this rectangle here and the diagonals, then you break them, and you just draw from O, you draw a line. This, since this is 10 and this is 15, so that's 35, and we need another 50, so 85 mm line till here, and then 25 till here. Now we have gotten the station point, which is S. So now we need to connect all the vertices and the peak of the pyramid to this S, which is 5 lines till S. After this, these intersections between these 5 lines that we drew and the picture plane, this is what we need to project downwards. 1, 2, 3, 4, 5, and 6. It's 5, yes, of course it's 5. And after this, we drew S dash, which is like at an arbitrary length. We chose 20 mm, by the way. It doesn't matter really. It could be like, you can use any length for that. After we have S, we just drew this line and then went 10 mm below. Now the observer is 50 mm in front of the picture plane and like 50 mm above the ground. So the distance between HL and GL is 50, but the pyramid is on the GL, but it's only 40 millimeters tall, as indicated here, 40 height, 40 mm. So Do you feel the difference? That's why HL and GL, they're separated by 50, but this pyramid, O dash, A dash, and B dash, this triangle, it has to be 40 millimeters tall because it's been specified here. So after you after making HL and GL, I hope you understood this 50 and 40 where this comes from. After this, project these A, B, C, D, like just A, B, and O on the GL. O only till here. And after that, connect this S dash with these 3 points. This is like the exact front view of the pyramid. Do you feel it? How perfectly aligned it is? This O, this line is perfectly traveling till here. This B till B dash, this is the exact front view. And connect S dash with all 3 of these points. And connect these 2 because this is the view. And like this is where the magic happens. After this, you project these lines till they meet these, till they intersect these lines that we drew in the previous step, and it'll already start tracing. So this bold image that we have drawn here, this is what the observer is actually looking at. If you see the station point is a little towards the left of the pyramid. The observer is a little towards the left, you see. So this is why both sides will be visible, and this is something that we see in this drawing as well. This side is also visible, but in the front view only this side is going to be visible. So I hope you're feeling the intuition of it. We drew this picture plane, drew this rectangle, got till S by drawing these diagonals, getting the apex, and since it says the observer is 50 mm in front of the picture plane, so we got till here 50 mm in front of the picture plane and 25 mm towards the left from the axis of the pyramid. We got till the station point, then we got till S dash, which is just an arbitrary length away. We chose 20 millimeters in this particular drawing, and after that we drew HL, and 50 mm from this we drew GL. Now after drawing this GL, go 40 up and draw a line, so we can get this shape after projecting these A, O, B points on the ground line. So we get the front view. Now connect these 3 and also all of these 3 points to S dash. Now we get 1, 2, and 3, these 3 lines. Now project these 1, 2, 3, 4, and 5. Project these downwards until they intersect with these 3 lines that I just talked about, which is S dash A dash, S dash B dash, and S dash O dash. When they intersect these till here, that's it. You get O where it intersects S dash and O dash. You get A, D, B, and C, and just draw. And the ones that are you're not supposed to see, they're going to be hidden, so you put them in another layer, which is wait, let me show one thing. This is where you access the layers, by the way, and this is how I get these lines which are dashed. See, there are different layers here. We can go into layer properties and you can just make new layers, or just do Alt N to get a new layer. So in projection, I changed them to dashed x2. So you might not see this when you're in the lab. So you double click on the line type and you click on load and you find dashed x2, which is this one. You should learn this. It's dashed x2 and select it, click OK, and select dashed x2 once again and just do OK, and change the line weight of the construction layer to a thicker size, which is 0.6, and other layer should be at 0.2. In output, when you're supposed to like make the PDF, this is a step where, like, if you don't know how to do this, what is the point of everything that you're doing? So click on Page Setup Manager. We're done with this, right? After this, you just need to trim some things, and that's it. This needs to be bold. It needs to be in a different layer. That's bold. Then do the dimensioning accordingly. Make sure, like, all these dimensions that are here, these are like 20 by 30. These are all that are given in the question. 30 by 20. It says 15 mm behind it, so we showed 15 mm behind it. Do you get this intuition that is behind the picture plane? And it says 25 mm to the left. We did this. 50 mm in front of the picture plane, and 40 mm is the height of the pyramid, and 50 mm is the height of the observer, which is 50 mm above the ground. So in this one drawing, there are two views. This is the exact top view, if you feel it. We're looking at it from here, so the picture plane becomes a line. And in here, the picture plane is like an actual plane. And like the HLGL, these are the HL and GL that we're seeing. And that is it. When you need to go into output, go into Page Setup Manager. In the output tab, here, in the output tab, go into Page Setup Manager and modify. And do this once, otherwise you won't remember these settings. Click on high quality print, and in plot area, click on window and window. Then just select an area that you think should be printed in the PDF. Click on center the plot and portrait and landscape accordingly, and click on OK. That's it. Then click on preview, and you will see how it looks like. Now, this drawing does have some faults, but it's mostly pretty accurate to what it looks like. And then just click on plot, and the PDF will be saved. Yep. In the lab, if you see pyramid or box written here, then you need to change. For example, this is what 3D modeling looks like. The 3D modeling workspace looks like. But we need to be in drafting and annotation, which is this one, for 2D work that we do. But 3D modeling is used for section of solids. So if you get that, please start with changing the workspace. If you don't have the tools, it can't work. So these are basically like every single thing. And dim sty as well. How do you make these arrows look cute? Dim sty. Type dim sty in the command box, which is here, by the way. And if this command box doesn't show, just click on Control 9. See? Now it vanishes. So if someone who was sitting in your PC click Control 9, or for whatever reason, if the command line is not showing, click Control 9. Like, press those keys so this appears. Otherwise, it's a lonely ride, mate. Type dim sty here and modify. Then what are the changes that I do? In the first lines tab, I make this 2 and this 2. And symbols and arrows, arrow size, it depends on the drawing, but something around 2 or 3 is what I generally use. This drawing is in particular, it's pretty big, so I use 3 here. Text size 4, and offset from dim line 2. Then primary units need to be 0, this 0, depending on what the drawing says and how much space we have. These are all the changes that you need. How did I draw this? Go into this in an annotation group, select leader, and snapping is off. Click here and this, let's say it's R10. Now change the text size from here, otherwise it's not visible. Enter. Now it looks big, but it's going to fit right in. And look. So this is basically everything you need to know to AC or EG practical. I guess, I mean, there are more things, but given the time and how much effort we're willing to put in, I think this is pretty good. Read these charts, they're pretty, I don't know, it's so fascinating. Alright, have fun, good luck. If you have any doubt, feel free to ask me. We learn and grow together. Thank you.